Lesson 104, Arithmetic and Geometric Series. Are you thinking we've already done this? And well, we kind of have and we kind of haven't. We did arithmetic and geometric sequences, arithmetic and geometric progressions. Sequences and progressions are synonyms, but series is not. Series is a little bit different. A series means start with a sequence, arithmetic or geometric, and then add all of the terms up. So I've got a sequence there, 11, 14, 17, 20, 23, ... And my sum is 11 plus 14 plus 17 plus 20 plus 23 plus ... Now, what kind of a problem do you see with that right now? How are you going to add up that bottom line and get to an answer? What's going to happen? What's going to trip you up with that? Eva? The ellipses. I keep adding bigger and bigger and bigger numbers, right? How am I ever going to get a final answer? So for today, all we are going to do is the sum of a finite series, one that ends. There will be in a few lessons some special cases where even with an infinite one, it is still possible to get a sum. It's kind of mind-blowing right now, but just something to think about for coming up, I think sometime next week maybe. So for today, let's start with the series that you see right up here on the board. They say this is arithmetic. Do you believe them? Elliot, you're nodding your head yes. Why do you believe that it's arithmetic?
You're adding the same thing.
Specifically, how much are you adding? So we've got a common difference of 3. So yes, we believe that it is an arithmetic series here. So this one, I have A1, A2, 3, 4, 5, 6, 7, 8. So this one, I happen to have an even number of terms. Specifically, I am adding 8 terms together. And I want to know what is the sum of all 8 of those going to be, and you're not going to grab your calculator and start punching in 11 plus 14 plus 17. What if I wanted the sum of the first 128 things in there? That's a lot of typing into your calculator and a lot of places to make mistakes, and it's going to take too much time. So I'm going to use this shorter one to show you a trick so that maybe we can see a pattern and come up with a formula. The trick is I want to start with the first and the last. So if I put 11 plus 32 together, what does that equal? What's my subtotal just for that first and the last one? So that's going to be 43. Then I'm going to work my way in. I'm going to take another pair of the ones that are next to each end. What is 14 plus 29? 43 again. Next pair. What is 17 plus 26? 43 again. And my last pair, what is 20 plus 23? So I happen to get 4 pairs, and each pair was 43. And if I multiply 4 times 43, I think I got 172. Did I do that right? So now let's look at what we did here. I had 8 things, and I put them in pairs. Isn't that just division? 8 divided by 2 would tell me how many pairs I can get. If I had 16 terms, I could get 16 divided by 2, or 8 pairs if I matched them all up. So what I had right here was my 8 divided by 2. Now let's match that up to make it a little more general. I had n terms, 8 terms, n was 8, and I divided my number of terms by 2, and then I took my first term plus my last term, which was my 8th term. So what I did was I had an even number of things in my list. I took that number of terms divided by 2 to see how many pairs I could make, and each pair added up to the same thing as the first one plus the last one. And that will work anytime I have an even number of terms. They'll all match up in pairs, and because it's arithmetic, everything is that common difference apart. All of those pairs will add up to the same thing. But before we can say we have a formula, we need it to work with an odd number of terms also. So let's see what's going to happen if we now have an odd number of terms. So basically I've just taken the same series and added another term to it. So now I have an odd number of terms, and specifically I have 9 terms this time. So I'm going to start trying to pair things up again. Since I have more terms, I'm not adding the same thing for my first and my last. This time I need to add 11 and 35, and now what do I get? So I get 46. Well, let's make some pairs. 14 plus 32, 46 again. 17 and 29, what's that? 46 again. 20 and 26 again. And what's that? 46, and that's all the pairs I can make, because I've got 1 left over, not 2 that I haven't used. So I've made 4 pairs of 46, right? So far I have 4 times 46, and I've still got that middle term. But I don't want to have to figure out the middle term each time, because sometimes they won't show me the whole series. Is there any relationship between 23 and 46? Becca?
23 is half of 46.
So I have a half of a 46 plus 46, or plus 4 times 46. So if I undistribute, I think that means I have 4 and a half times 46. So my 46 was my first term plus my last term. N was 9. Is 4 and a half 9 divided by 2? So it is still n divided by 2, so I still have my same formula, even when it is odd. And so for this particular one, if I added all of those up, I would have 207 as the sum of the first 9 terms of that series. So our general formula, which we'll put in our formula list in a minute, will be whether it's odd or even. If it's arithmetic, we take the number of terms that we're adding over 2 times the first one plus the last one, and that will give us our sum. On homework problems, when it says to develop or derive a formula for the sum of the first n terms of an arithmetic series, I'm not going to make you do this, because you've got to come up, every single time you'd have to come up with specific numbers to do it. And so on arithmetic only, I'm replacing those questions with just write down the formula. So part A would be write down Sn equals n over 2 a1 plus an. No numbers on it. And then use it for part B. Geometric, which we're going to do now, I do want you to derive in general. We're going to do a geometric one with just general variables that fit the pattern, not specific numbers of 11 and 14 and so on. So, you ready to move on to geometric? Don't see any hands up for questions, so now let's do geometric. Since we are going to do this one in general, we want to start out with a general finite geometric series. So my first term is A1, my second term is A1 times R, my third term is times another R, my fourth term is times another R, and so on. If I am adding up n terms Remember, my nth term is first term times r, not to the n, but to the n minus 1. So that's why it ends with what you see right there. Now, my trick is I am next going to multiply that entire series times r. So I'm going to take r times that whole series. So I need to multiply r term by term by what I just wrote down. So I'm going to take a1 times r, and I get a1r, but I'm going to write that underneath the matching a1r. And then I'm going to take my second term, a1r, and multiply that by an r, so I have plus a1r squared, and again I'm going to line that up. Then I'll take the a1r squared times an r, so I've got a1r cubed. And then I'll take the a1r cubed and multiply that, but that is just going to be part of my ellipsis right here. I'm not really going to write it, but it's in there. Now, in this ellipsis, also hidden in here, the one right before that was an a1r to the n minus 2. It was hidden right here in this ellipsis. If I multiply that one by an r, I have a1r to the n minus 1. And then if I multiply my last one by an r, I have a1r to the n. Everybody with me on what I did right there? A bunch of terms are hidden in the ellipsis, and that's okay because I'm doing this in general. I don't know how many terms there might be in that. Then what I am going to do is to subtract my rows. So on the left, I have Sn minus Rsn, or I could factor out the Sn times 1 minus R if I wanted to. Now when I subtract all of these, A1 doesn't have anything that it cancels out with, so I have A1. But I have A1R minus A1R, A1R squared minus the A1R squared in the second row, and so on, and so on, and so on. But then all that I am left with is 0 minus that A1 r to the n in that second row. So everything canceled except those two. And hey, those have a GCF also. So I'm going to factor A1 out, and that's 1 minus r to the n. So if I want the sum of the first n terms in a geometric series, I don't even have to know the last term. And you know A1, multiply that, 1 minus r to the n, and divide that by 1 minus r. And now we have our two formulas. You will be expected to do all of this, what you see on the board right now, as part A of the ones that say develop a formula for the sum of the first n terms of a geometric series. So be sure you can do that on your sets. And let's write these down so that we can remember them. Now, it will be nice if every time they ask us about an arithmetic series, they tell us the first and the last term and how many terms we're talking about. But sometimes they won't. So we need to also remember what we have already learned, that if it is an arithmetic list of numbers, we know that the nth term is the first term plus n minus 1 times d. So if they don't give us the last term, we could use that to figure out the last term. Or if they don't give us the first term, we could use that to figure out the first term, because in this formula we need first term, last term, and how many terms we have. And if they don't give us all of that real clearly, we have to use that other formula to figure out what's missing. Similarly for geometric, label that was for arithmetic. For geometric then, the nth term would be the first term times r to the n minus 1. So if they give us the last term, but don't give us r, or don't give us the first term. We'd use this formula to figure those out. So you guys about ready to try some examples here with this? All right, let's try our examples then. So let's find the first term, to find the sum of the first 14 terms. This one is going to be arithmetic. So we need to use our arithmetic formula, which is the sum of the first n terms is n over 2 times the first one plus the nth one. So we want 14 terms, so 14 over 2. Do we know the first term? Everybody shout it out. First term is -3. Do we know the 14th term? So we had to find it. So that's what I'm talking about. We need to find the 14th term so that we can plug it in there. To do that, we're going to take the first term, and help me remember how that goes. Kate, what do I do with the first term to get the 14th term if it's arithmetic?
You add the common difference times 13.
So we need to add 13 times d. Exactly right, thank you. So we know the first term is -3, and we know the common difference is -2. So -3 minus 26, I think I'm needing to add -29. Does that sound right? So I'm going to put a minus 29 in right there, which means I have -32 times +7, which gives me -224 for what I would get if I would add up the first 14 terms. Does that make sense to you? If I have -3, and then I'm adding -5, -7, I am adding up a whole bunch of negative numbers in this case. So it seems to make sense. So far, so good. Thumbs up, thumbs down, everybody. I don't see any thumbs at home. Thumbs up, thumbs down. Making sense in class? All right, let's move on to another one. I have 2 more examples that I will do with you. So this time, let's do geometric. So if it is geometric, the sum is the first term times 1 minus the common difference to the nth power over 1 minus r. Do we know the first term? If we do, shout it out. -3. We're trying to find 10 terms, so n is 10. Do we know r? Shout it out. Now we need to be careful. That is 1 minus r. So we need to make sure we are taking that whole -2 to a power. And in this case, to the 10th power. And then over 1 minus the -2. So my denominator is easy. 1 plus 2 is 3. My numerator is 3 times 1 minus. Now, will -2 to the 10th be positive or negative? Will just -2 to the 10th power be positive or negative? It's going to be positive, so I'm going to have 1 minus a positive number. Specifically, I'm going to have 1 minus positive 1,024. So what I have is that my sum is 3 times -1,023. Oops, -3, I dropped my minus sign there. Times minus 1,023 over 3. So I now have -3 times -1023 over +3, 2 negatives. Final answer is positive. My 3's cancel, so my final answer is positive 1,023. Not too bad, just need to watch out for the plus and minuses and not drop one like I did. And be careful with raising negative r's to powers. Okay, this time, again, we want the sum of 5 terms of a geometric series. So once again, we want to use our geometric formula. So I'm going to need the first term, 1 minus r to the n, so it's going to be 1 minus r to the 5th over 1 minus r. Do I know the first term? Well, do I know r? Well, they're not much help in this problem. I'm going to have to figure both of those out. So now I need to go to, what else do they tell me in the problem that might help me figure things out so that I can plug into my formula and get my answer? They tell me that my third term is 4, and my 6th term is a half. It's geometric, and I know formulas for the nth term of a geometric series, so I know that third term is the first term times r to what power? Squared. And my 6th term is my first term times r to what power? To the 5th. Okay, 2 equations, same 2 variables, a1 and r. So I've got a system that I should be able to solve. Can I take my top equation? Is it okay if I divide both sides by the same thing? If I have an equation, can I divide both sides by the same thing? You better be saying yes. We can add the same thing to both sides, subtract the same things, multiply, divide, as long as we do the same thing on both sides. So, 4 and a1r squared are the same thing, right? And they're not 0 if it equals to 4, because 0 is the one thing I can't divide by. So I am going to take my top equation and divide both sides by 4. But on one side I'm going to write it as 4, and on the other side I'm going to write that 4 as a1r squared. So I am looking at 1/2 divided by 4 over 1, and that gives me a1r to the 5th divided by a1r squared. My a1's cancel, and what do I have on the right? How many r's on the right, everybody? 3. 5 minus 2, I've just got r cubed. On the left, if I have 1/2 divided by 4 over 1, that's the same thing as 1/2 times, flip my fraction, 1 over 4. So if r cubed is an 8th, what is r? R is going to be 1/2. Could it be negative 1/2? Do I have 2 choices there, like I sometimes do with geometry things, or geometric ones? No, because cubed, we can only have positive. Negative 1/2 cubed would have been negative 1/8, not positive 1/8. So now I know my r for my formula, and I still need a1. So I am going to go back to one of my equations. I'm going to go back to a1r squared equals 4, so I don't have a fraction of 1/2 in there. And I've got a smaller exponent on the r. That one just looks easier to me. So if 4 is a1r squared, and r is 1/2, I am looking at 4 is a1 times 1/4, or a1 over 4. So what does a1 have to be? Elijah? It needs to be 16. Now I can plug my 16 and my 1/2 into my formula over here. So I've got 16, and then I have 1 minus, and my r is 1/2. And I need to raise that to the 5th power, and that is over 1 minus. And once again, r is still 1/2. And this is going to give me the sum of the first 5 terms of that geometric series. So let's see what we get. 16 is easy. Denominator, 1 minus 1/2, that's not too bad. That's going to be 1/2. And then I'm going to have 1 minus 1/32, I think. So 16 times 31 32nds divided by a half. And since I don't want to have to deal with that half in the denominator, I'll multiply numerator and denominator by 2. So now I just have a 1 in that main denominator. In my numerator, I have the 16 times 2 times 31 over 32. So the 16 times 2 will cancel that 32, just leaving me 31 for the sum of my first 5 terms in there. How do we feel about that example? Does it make sense?